Good morning, it's Anagon Live, and it's a little bit earlier than normal, and that's because day 15 is still going on for me. I haven't finished part 1 or part 2 yet, and so we have about 1 hour of time before the next day starts, and I'm gonna try to finish what I started. And yeah, I do need to pick up from where I left off yesterday, and yesterday I was writing the maze solver. We have a little robot in a space station and it needs to find some kind of oxygen system, and I have looked already at other people's solutions, but in fact my solution was pretty much the same, and I'm mostly just debugging and seeing where it goes wrong. So yeah, let's have a look how far I got yesterday. And so I have a robot and it is actually exploring. As you can see, it draws a map of where it went, but I think there's probably something going wrong. Maybe the state of the robot is not reset correctly. That could be. Let's see, that could actually be. So what I am doing different from other people is that because you need to explore breadth first search to get the shortest path to the target, you actually need to jump from different locations. So let's say you're in this location and that was the best path so far, and then you need to explore this location because that's the shortest path after. Then you basically need to move your robot to the other position, and that is really not possible with the program that the robot is running. So what I'm doing is I'm keeping the state, and I'm loading it at every start of the robot's movement. I'm loading the state, and then afterwards, after I've moved, I'm saving the state also. So that's what I'm doing, and it might be the case that the way I'm saving it is not correct. I'm not entirely sure, and I thought first what I could do to kind of verify that my search algorithm is correct is to kind of use a fake robot that has an internal map of which I know what it looks like. But now I realize that if the state is actually the problem, the robot state, then it wouldn't help me a lot. I would have simulated the part that actually has the bug. So for now I think I'm going to go through the robot's steps, like one iteration at a time, to make sure that what it's doing is really correct. And so let's start the loop and go and run it. So at the start of the loop, we might also want to say where we are, just to be clear. So our previous position, or let's say that hey Crespel, good morning and good evening. Welcome. You missed the stream yesterday because this one took me a long time. Yes, it took me so long, in fact, that I'm still working on it. And that's fine. Did you manage to finish it? So our current target position is this one, and I'm also going to print the current position right here. And it looks like previous position in that's also confusing. So I have target position and previous position, but if this is the previous, then this one cannot be the next, right? One of them must be the current position. You did eventually finish it, but not before spending too much time with interactivity and display. Yeah, that's another thing I thought of yesterday. Maybe if I would make the whole thing interactive, I can really feel if it's doing things correctly. But I thought also that it would take a lot of work, and interactivity is not that easy in a console. You would have to press like letters all the time and enter after every step. So I'm going to say that so the visit list is where we are gonna go, and then previous position I will just call it base position. That is a little bit less confusing perhaps. So from the base position we need to go to the target position, that is our to visit item, and maybe I can do it like this. And okay, yeah, the robot state, I don't think I can actually visualize that. It is a lot of data, so yeah, nothing I can do about that. But the direction is also available. I might want to print that. This. So I really hope I can finish this robot, at least part 1, before day 16 starts. That would be really great. So what do we see? We are in 0, 0, and we're going up. And we're saying that we're going up also. And I want to visualize that direction a little bit more explicitly. So I'm using a list of characters. North, south, west, east. I think that was the order. Yes. So how is it for others? Has everyone finished day 15? Or are some of you also still working on it like me? I see on the leaderboard a lot of people have stars. But I think this might be the first puzzle where really a lot of people kind of dropped out. And here I'm doing a modulo rather than using braces to index correct position. That's why we saw a 1 in the output. Okay, so yeah, we are going north, so that's correct, and we're loading the robot state for this current position. And for position 0, 0, I do save the robot state just before the loop, so we should have a correct state. We should at least. And when we run it one step, what happens? Oh yeah, okay, let's go line by line actually. So we load the state, we input the direction, and okay, that is something also interesting, that when we load the state, we're not really overriding we're overriding the state, then we're doing input, so it would append it to the input. So if we had any input at that point, we would have a problem. So I don't think it can happen, but I'll just raise an exception here. So we already got some input, and that is bad. I don't think it would happen. But yeah, at this point I don't know where the bug could be, so just adding different checks here and there. Okay, so we have state is 0. That means that we found an empty space and we moved correctly. And we're adding it to the visited position, and we have a status, a direction, and previous steps. That's how many steps we took earlier on. And I'm reading that one from the list of visited positions. Sure. Okay. I'm just figuring out what I wrote yesterday. It's been a while. And oh, it says actually we found a wall. And 0 was a wall actually. So we go north and we find a wall. And then what do we save in our visited list? We visit. Oh, okay. We're saving the wall actually. Even though the robot did not actually move there. Is it a problem? I'm not sure if it's a problem. And I'm not saving the robot state for that position. And I guess it's okay. Because okay, let me show you what I'm thinking about. So we have a robot here, and it's just in front of the wall. Like this, and it was trying to go up and it didn't go up. Now I do want to keep track that I tried this location. Why? Because just in case, let me redraw the wall. But just in case we have a wall like this and another time we would be here and we are thinking should we go left or not, then we do want to know that this location was visited and that we have data for it. But do we need the state for that position? The position here? No, because we're never going to start from there. We are not supposed to. So that is not needed. So from that perspective, I am saving the target position in the visited list and I'm keeping the status and the direction that took us there and how many steps it took to get us there. Although that doesn't make a lot of sense because we can't even move on from there. Okay, and then if we don't have a wall, oh, we just jump a whole bunch. It could be that that is because I added some lines while debugging. So back to where we were, jumping line by line. Hey, I see I already got input, and that is because what? What exactly? If we already have input at that point, that's really incorrect. What about that inputs? Oh, hold on. I have inputs and input. Input is the function. Okay, right. I'm checking if we have a method to input anything. Yeah, of course we do, so that makes no sense. Okay. So, no crashing here. And what happens? We go north still. And we pop in the status that we found. The robot output should have only one value in it, excuse me. That's true. And let's see, we save it, okay. And we say that we found a wall. And if we didn't find a wall, we're doing all of this. And otherwise, we're going to save X and Y, or we're extracting X and Y, because it means that we didn't actually move. And we're not doing anything with that data anymore. Okay. Right, so this part seems correct, and we did save this. We did not save the state. Is that okay? We did pop the output, and we did save the state before, so we can probably just reload it, and it should work, technically at least. So we're going to the end of this section of the loop and load again. And now you can see what our map looks like. We have some positions on the y-axis with minuses because it goes negative up. And then we run again. So we're loading the robot state and we can see what that looks like. Our execution pointer should also be in the state. It should be, and I'm assuming it is. Maybe I can check this. So instead of loading the robot state with the execution pointer at the second position, I'm going to put it at the first position. Oh, by the way, this is how I load it, and this is where I'm extracting from the parameter. But from where we are getting the state, I'll just do it the reverse way around also. And we have the positions and the inputs. I'm just going to put inputs there also. Oh, good question, Crossbolt. No, it doesn't include the relative base. And that might be why it's going wrong. That is very likely the reason why it's going wrong. Yeah. And I think I didn't catch it because I'm writing it in the Intcode computer for day 9, which is an extension of day 7, which is an extension of day 5. So I didn't actually look at all of the variables involved. Thank you, that's going to help a lot. So relative base is what we need to save also. Now I learned something yesterday, and I've seen it before, but I haven't really applied it in practice yet, and that is named tuples. And I would like to try that. So I would like to make a named tuple. I don't really know how to do that. I think I can find it in one of the codes from yesterday. I think it wasn't in here. Maybe it was Alex's code? No. And I looked at only 2 examples yesterday, I think. I have a scratch file still. No? Okay. Maybe I can do a search for named. So it's from collections actually that you... okay. So here I have an example of a named tuple. I want to use a named tuple because this state has a lot of parameters and just don't want to be confused, and also I want to try how it works. It is a helpful function. So we call it computer state, and it has an instruction pointer. It has inputs, it has positions, and it has waiting for input, and we need the relative base, and I will put it right after the instruction pointer. Like this. And then here I can return the name tuple. I guess I have to assign it to something like this. Computer state. And when I load it, I guess I don't have to do anything. That's really handy. And it says my line is too long. Well, that's something I don't care super much about. Except for that you can't read what's on the end of the line. That is not convenient. I really hope, Crosspot, that this was really the issue and that now my robot will do something that makes more sense. So let's run it step by step. So we went up, and then we went down, and then we go left, and there's space, and right also. Okay, so far so good. I think it's already better than before, because before, oh, it looks a little bit like before. Okay. Wow. Just keeps going. Oh, we got an error? Or did something else happen? It just looked for a second that we got an error because it just went to my debugger. Maybe I can use my keyboard to go to the next step. Yeah. Oh. And it stopped. Okay, so far it seems to be fine. Yeah, and it's going in different directions than before. So let me just run the whole thing and see where it goes. Actually, this looks pretty much the same as the maze I was producing before. I didn't realize that it started at the right, actually. So the relative base, maybe that was not the issue after all. Or maybe I'm not saving it. Am I saving it? Or does this not work the way I'm actually destructuring my state? I'm assuming it works. We can try it actually. We can just break and see if it's loading correctly. So here I have the state. The state looks like this. Okay. And then after I load it, it should be fine. But of course, it's mostly in the second iteration where you would see the difference. So the current robot state, what does it look like? It looks like this. No inputs, instruction pointer is all the way at the start, and relative base is 0. Oh, so our state didn't change at all. That is kind of... Well, it might have changed. Maybe the positions, like our int codes, has changed. That can be. So we can look at the robot's int codes and compare it maybe with... we can compare it with the current robot state. No, compared to what we saved before. So robot states dot positions. No, robot state dot positions. That looks like this. And the current robot state is positions. I hope we printed that. Let's see if we did. Okay, so now we have the two states and we can see if they're different. Although apparently I cannot copy it, and I hope that my keyboard didn't break. Recently I have some problems with my keyboard, that it freezes up. It's the caps lock key that like never wants to be depressed. And I am working on a MacBook, and it is apparently a common problem among those who use the MacBook Pro from last year or the year before. And I would really regret if it broke, because I really like it. Okay, so comparing these two files. Actually, I still don't know in PyCharm how you can quickly compare two files that you have open. Like, well, I guess you can just do... Yeah, you see I open compare with, and then I can open a file. It's not that handy. Another way is compare with, and then what happens, I can also open a file. I can do compare with, compare contents, doesn't do anything. So what I usually do now is I do compare with clipboard. I copy the other file and then I compare with what's on my clipboard. And I want to see if I have any differences. And it kind of looks like I don't. And those two files are not different in length, because one side might be a little bit broader than the other. So don't be too confused about that. Maybe I can do them unified. Okay, so it looks the same, but did I actually debug it correctly? Well, maybe the state doesn't change for the first step. That is possible. That can very well be. So let's go to the second step then. And the second step is, we are at the start and we've explored up and down already, and we're gonna go to the west side. But our initial state is still the same as where we started, so I'm going to go here. Yeah, that's better. So now we're... Oh, it means we're still going to explore from the center. I want to find a case where we're not exploring from the center, because that's where we're actually using a previously stored state. So we're starting at -1, 0. That's actually not what is shown on the map right now. And then we're going to explore north. We're going from here to the top, and we're loading the state. And the robot state looks like this. The relative base is still 0. And I wonder if the relative base was actually 0 after we went to that position. I'm not sure I can actually figure that out. I'm just doing a random check because I feel like I'm a little bit lost. I'm doing a double check that we didn't visit the location that's on our list. I think it probably can't happen, but let's say if target position is in the visited list, then we're also going to raise an exception. And if you know any better exceptions to use than value error, I just wanted to raise an exception like this, but I can't use a string like in JavaScript, so I'm just using whatever came up first. It's value error. Please let me know if you do know. Already visited position. This one, I don't think it would happen. As you can see, it doesn't happen. And there we are again. It looks again like this weird kind of Yoshi kind of shape. And I have seen the output because yesterday we discussed the output. We discussed the puzzle, and I could see that if you actually run it, I'm not sure if it was this one, made by Fuzzy. Could be that one. And it showed like a pretty clearly square grid with paths that go up and down and around corners, and nothing kind of like zigzag lines, nothing of the sort. So it's a very slow puzzle, so it takes a bit of time to get the output from Fuzzy. And I want to see if we can use that. So, and why we have 40 minutes left before I need to have a break and eat a bit, and then we can prepare for day 16. So I do want to solve it in 40 minutes, and I think at this point I understand logically how to solve the puzzle, but I'm just having problems with the implementation, and I don't mind to kind of help myself a little bit using some hints, like knowing what the grid looks like. Although it does feel a little bit like cheating, and I guess part of the point of Advent of Code is learning how you can figure out these problems and debugging your code when all you have is a big input file. So while we're waiting, what could we do to actually figure out why the robot isn't doing what we're expecting? Maybe it's that we're not resetting outputs. Could that be the case? Let's say that we're also checking for outputs. That one is called output. Maybe I can run my code at the same time as Alex's code. The 15. Yeah, no, we get the same problem. We're popping from an empty list, which means that we visited all locations, but we haven't reached the goal yet. So what is happening when the robot says it's checking -1 but draws its position on the map at 1, 0? Or maybe I'm just misunderstanding the output. Let me show you what happens. Actually, the map that you see is the previous map. So hold on, so here I'm saying we're going to be at 0, 0 and we're going to go up, so -1. And then when it draws itself, actually didn't move, so it's still at 0, 0. And then now we're in the next iteration and we're going to start from 0, 0 and going to the south. So it is a bit confusing the way I draw it, because I don't draw before and after. I only draw after. So I could make that a little bit more clear by printing some kind of separator. Like this. And then we run it. Yeah. And so far I don't think I've found any cases where the positioning doesn't match with what the robot thinks. It would be great, of course, if we could look inside the robot and figure out where its state is stored, like its position, and then we could just basically like hack into it and see if it is correct. But we have a lot of positions, and we do need to know where it actually changed. So here I see a -1. That could be no, actually not, because we're going to load the state. Hold on. You know what, I'm just going to go over the robot a few times. No, I can't. I was gonna say I'm going over the robot a few times until I see like a quickly identifiable position, like -2, 3 or something, and then look it up in the robot state. But if our robot state is broken, we're not gonna find it there. So that also wouldn't work. And our run has completed, I think. Oh, but we don't have a map for that one. Maybe it was this one that has a map. Yeah, it does. Okay, so this is what it kind of looks like. And we have an add position, and that might be the cooler, or it might be the oxygen tank. The robot or the tank, and it's the tank actually. And the robot is not drawn on the screen. And so from the map we can't really see where we are starting, which is okay. But as you can see, all of the empty spaces are horizontal unless you're moving to another line or moving a few lines down, and you don't really see like a zigzag going on like you see in mine, like this. So that is not correct. I'm not doing any backtracing, by the way. I just saved the robot state and I'm loading it as I'm going to explore different areas. Maybe something specific about how I'm going around corners. I wouldn't think so, because I'm not really going around corners. I'm just going to all the places around me except the ones I visited. I could double check my expansion logic. So how I do it. If I didn't hit a wall, it means I did move, and that means we have a new position, which is X and Y. And then we're going to explore from there. And I am calculating the opposite direction so that I know how to go back from where I was, but I think that we are not using that anymore. When I highlight my code, I see no occurrences of this one, so opposite direction is not needed. It was for a previous implementation where I was actually going back, but now I have the state. So, yeah, okay, so this is still correct. I'm retrieving the state and I'm saving it into the target position, which is the one where we just moved. And then I'm making a list of all the excuse me, positions that I've visited. So visited contains no, that's to visit rather. To visit contains both the previous position and the direction and the target position. I want to get only the target, and maybe I'm taking the wrong one out of that. So it has three elements in the tuple, and the way we extract it here, you can see that the target position is the second one, and I'm popping the second one. Yeah, I'm ignoring the first and the last one, and the second one is popped. That will be the actual tuple of XY coordinates of what we're visiting. Okay, so then we know all the positions we visited, and then once we check all of the directions that we might want to check, we can make sure that we're not going to double check one where we've already been. And so the position that we need to look at is basically the target position, which is where we are right now, and I can replace that with X because I have it in a simple variable. And the target is X plus dx and Y plus dy, and this will be provided by the direction items. Direction items contains that's not so clear to see. It actually comes from the values of the dictionary, and you can see that we have the following directions. Those are just the x and the y's for all of the directions, and I think there's probably no mistake in there. Let me double check it. North goes up, south goes down, west goes left, and east goes right, but that's also correct. And then if our position that we're thinking that we might visit is not in the visited list, then we're going to add it, but it also should not be in the list of positions that we might want to visit. So that means if we are exploring around, and let's say we have reached this place, but from another kind of branch we went this way and we are here, then we shouldn't okay, let's evaluate this position. For the second time we are near there, we shouldn't visit it. One, because it is already in the visited list to visit, and also if we would visit it from the first position, like here. And then in the second case it would be in the visited list. So there are two cases where we want to say don't explore that area. Right, so that we append to the list, and we have the to visit position, which is the new one, and the target position in this iteration is actually where the robot is right now after moving. So that looks correct to me. Yeah, really, like I can't find a hole in my implementation. The only thing that could really be wrong is the state. That's really where I find it's a black box, and it could really be wrong. So what can I do to verify the state? Oops, I want to delete root code. Maybe I can do a diff for two lists in Python and just compare that I'm actually overwriting a state with a different state. So we can apparently do sets, but that's not what I want. And this is on sets. No, I don't want that. Well, I guess I can compare it very easily using zip. So that's what I will do. So we are loading the state for that position, the base position, and let's compare it with what the robot has right now. So for every part of the state then we're zipping the robot state with the current robot state. I only want to compare the inputs actually. So like this, and then then we have, let's see, the loading state, like the old state, and the current state. And if they're different, then we have a problem. No, then it's actually correct. Maybe I can just print this whole zip thingy. Maybe I can do that. Or maybe not even print it. Maybe I can just evaluate it. Let's do that. So we're running. You're not very familiar with Python semantics, but is there a chance that you're getting shared references? Yes, there is a chance. And the way I was solving that is by making copies. That's at least what I think I was doing. So we have here a slice of inputs from the start to the end, and here also, and that should give us a copy. Let's see, we are here. Yeah, so that's something I was definitely concerned about. So I'm going to still write this little for loop. I'll just call it AB, like this. And if we find something that is different, then it's correct. Let's say the state is different is not the case unless we find an actual proof for that. So if A is not B, then the state is different. And then we'll print also loading state and different is this little variable, and then just let's run it and writing that it's true. So in the first few cases the state might not actually change because we've tried to move but we didn't move. So it's correct for the first case, for example, and for the second case also. As long as we're starting from 0, 0, our state is not going to be different. Basically, actually, as long as we haven't explored and moved, it's different. Does it copy the mem and positions? Yeah, it does. Yeah, I think actually I'm seeing right now a bug already. So now you see that the robot did move, in fact, and after it moved, we're now going to the next iteration, and it says that the states are not different. So that is really an indication that something is wrong, because I think... Oh, what just happened? I think it just ran by itself. That's weird. I didn't click anything. Oh, but I see. My finger was above the touch key on the Mac, so I think I just pressed it. Always mistrust yourself before you mistrust your computer. So here we move to the left. That means we should really have a different state. If we don't have a different state, then our robot's computer program cannot actually determine where the walls are. So I think really that the way I'm saving states is wrong. And maybe what I could do is right after moving to the left, seeing that I'm getting a state that is really different. So here we run the program and the state should really change at the point where we get status 1. So let's break when we have a status that is 1. And then compare the states of the robot. Can we do that? So before we run it, we do load state, and then after we run it we have a new state. So then technically we can compare the previous with the new state. So let's run and go. Hey, I got some kind of error. Name status is not defined. Why? Oh, name status is not defined. I actually just missed where that error occurred. Let's do it again. Console. Here we have no problem. And then we have my breakpoint cannot actually break because I put it on the part where the variable is defined instead of after. Yeah. Alright, let's see. We have now a part where we're loading the state and we keep running until we hit status is 1. That should be around here. But we don't stop actually. Why do we get it like this? Wait, is 1 actually the status that we're looking for? 1 means empty, yeah. I have a feeling that something is not going right. Let me run it again. Okay, this is the first time we stop. And okay, that looks correct. We haven't drawn the map yet at this point. So we have moved, and that means that we can look at the robot's internal state. And the internal state looks like positions. And yeah, we can just print it like this. And maybe we can compare it with the state that we loaded. So that was robot state inputs. And if we make it into a list, we can basically see pairs. Oh, not inputs, but positions. Excuse me. So here we can see all of the positions, and we can maybe go through it. This, you know, sometimes you go through something like this and you right away see that something was different. But it is a very long list, so I guess we can't. So let's iterate and find all the pairs for AB in zip. If A is not B, then we run that. Invalid syntax, maybe like this. Yep, and we actually get nothing, so it does look like the state is really not different. Oh, but hold on. That is still correct because we started at position 0 and we're going to the left. But no, after we go to the left, we should have a different state, really. I believe we should at least. Maybe the state is not so much in the positions, but rather the instruction pointer is different. Of course it should be different. robot dot instruction pointer is at position 0. Suspicious. Relative base is also 0. What else do we get? What else do we have? We have output. That is 0. How can that be? Is it because we do run program or something? That we are actually clearing things? So we're loading a program if we provide it, and otherwise we're just going to do the execution loop, and that's all. So I think I'm going to have to use debugging on the robot. So either I'm doing something very wrong with the way I'm checking my code, or the robot actually is not working. So here we have one input and we have a relative base of 0, and that is after we run the program. That is a bit strange, because actually after we run the program we should have no input left. So it's running. You see, it says waiting for input. Oh right, actually this is the output and this is the input. Okay, so that's still fine. Yeah. Hey Userman2, how are you doing? So okay, so we have no more input and we do have output, and we have RB here, and the instruction pointer is visualized here using using in. So it means we're at the start, and this was the second iteration or so. You're also trying to get day 7 part 1. Oh, okay. So you're working on one a bit before, so that means you're still working on the int code computer with relative bases, I think. And are you stuck on anything in particular? Or anything you're having trouble with? Oh, the one with the feedback loop. Ah. Let's see what day 7 was about. Yeah, maybe? Yeah, it's with the amps. Yeah. That one. Yeah, it's, you don't have to change a lot in your code, in your computer, but just need to make sure it can hook up. Yeah. Okay, so this is all the code of the computer. It's really too much to look at, actually. And it's so difficult to see if anything changed, but I can try. So the previous state was this one. Starting here. And I can't highlight it. I can't like hold my cursor and highlight all the way to hold shift and then click. So I have to drag it. That's a bit inconvenient. That's that one, and then I want to compare it with this one, for example. So let's compare this one with clipboard. Oh, we do have a difference. Okay, that's good. And okay, so at this point we're actually at a different position. Okay, because it says GT, which means jump to, a jump if true. Here it says 1, and it's going to jump to position 0. So it's just returning basically. Okay. I think the robot debugging mode is not helping very much, but I really want to make sure that our state is actually different when I'm loading it. So let's say we're starting with a different position. It still says loading state is not different. I'm not really sure how that can be. We made a nice tracer function for the intcode CPU. Oh yeah. More noting important stuff here. tracer function, and what does that do actually? What does it trace? Like every instruction? I don't get it. Why don't we get a different state every time? Am I saving the state or something after reverting it? If you're having logging on, then you're calling it every time an opcode is called. Yeah, that's handy. It might be a bit more handy than the way I write it right now, because I'm printing my entire program. Oh, that's something I could do also to kind of get a look into what it's doing. Man, it starts, I think it's almost time for coffee. It's difficult to debug a virtual CPU, it definitely is. Okay, so let me look at it again. So we're loading the state at the start of every iteration, and after we moved, we're saving the state, we're doing the robot.get state. So if we got a 1, that means we found a empty spot, it means we moved, it means the robot state must be different. Unless, of course, no, it must definitely be different. If it's not different, then this cannot work, cannot possibly work. Maybe I'll compare it here after running the program actually. Yeah, that makes more sense. Because if we're continuing from the last position, then we wouldn't actually have a different state, I think. Run robot state different, true or false. It kinda got annoying of trying to debug the virtual CPU. You also added in and output hook functions. It can also be handy. I don't have that, I just pass it. I just kind of loop and wait until it needs input and then add input to it. Okay, so now we're checking if the state was different and it says false. Even though, wait, even though we found an empty space, but I want to show that actually on the screen. So we found an empty space and it says that our state is still not different. That is just weird. And I'm looking at the robot state. Oh man, no way. I'm checking the inputs instead of the positions. Okay, do we get a different state now? Okay, we don't. So we actually are gonna go west, and we did go west. It didn't print the map yet. And even though we went west and we found an empty spot and the robot has technically moved, it says that my internal robot state is still the same. I don't see how that is possible. That cannot be possible. Day 15, it's causing you a lot more trouble, Crespo, and you went back to buffered IO. Yeah, oh thanks, you mentioned it, that I was comparing inputs. I already figured it out before I saw your message. But now I'm comparing the positions, and at this point I look at the state that I loaded and then I compare it with the other one. You know what? Why don't I actually make this copy a little bit different? Instead of doing a slice, I'll use a list. Or maybe I should make a copy on loading also. Maybe... Oh, yes. I should make a copy on loading. Because that's... yes. Is it really true? Yeah, I should do it when I load also. Oh man, and not just for the inputs, also for the positions. Okay, so I figured out what went wrong, and I'll explain in case it wasn't clear right away. So I have my robot here. It has some wheels and an antenna. And did I classify my encode CPU? It is a class, yes. Well, I can show you if you want. And it has an internal state here. And when I am visiting a position, so let's say we visited here, then I'm going to retrieve the state from the robot, but it's a copy, and I'll indicate it with a plus. And then I'm going to save it into the list of states here. And so this one will be copied here, and it's a copy. That's fine. Now we're going to explore from here. Let me draw it in white. And we want to go, let's say, here. So that means we need to load that particular state. And what happens in the current code is that I was loading the state into the robot, and I'm running the robot. Okay, and then the robot is now here. But actually I didn't actually copy it. I made a direct reference. So after the robot is now here, O plus was changed into O plus plus, but the state was also changed. And so that means the next time I'm going to explore, like here, and I'm loading here a copy. No, I'm not loading a copy because I'm only copying on write. That means that I'm getting a different state to start with. Actually, I would actually load it into this position. But so I'm not getting a clean copy. Oh, I thought that just copying on read would be enough, but it's not enough. And I guess what helps, what I could have done, no, I don't know. Okay, I was thinking maybe when I run the program I should make copies or something, but no, you can't do that. Okay, now let's see what happens. We're still making the same Yoshi pattern, so I'm not sure if my solution worked. Is this a mutability issue? I'm not sure if that's the right way to describe it. I think it's a reference issue, so I'm reusing the positions, the int codes for different states. And I really feel like this copying method I'm using, this trick, is not correct. Let's actually test it. So let's say we have A, and then we make a copy of A, or a reference, and we change position 0 into 42. Now look at A, it's also changed. Now let's say A is again what we had, reset, and now B is going to be a copy of A, like this. So no reference, and we're changing B, and then we're looking at A. Okay, A didn't change. So it's really, this is doing what I thought it is doing, and we have no problem there. And relative base, I don't copy relative base because it is an integer, and integers, they don't pass by reference. So I can safely do it like this and say, okay, well, if I'm doing B is something, I'm really overwriting. I'm really overwriting the whole variable, so this is not even testing references. So to do that, I would have to do something like, let's say A is 1. So let me copy this one into, hold on a second. Userman is saying that will copy refs over though, using copy. Yeah, you're saying I'm copying refs, but what if in that list I contain only integers? That should work, right? So my case was like 1, 2, 3, 4, and I'm copying it. Well, ints are immutable. Yeah, okay. But now I can safely do this, right? Oh, that's not Python. B0 plus equals 1, and B should now be incremented and A should not be. Yeah, it's really fine. Oh, so you're saying if it's an immutable data type, then basically you don't need to worry about references. Okay, makes sense. So if the reference is not an issue, if the copying is not an issue, then I should actually show that the states are different, right? Deep copy would be the solution for mutable list copy. Okay. Well, I think I don't have a mutable list in that sense, so it should be fine. And let's look at the time. We still... Oh, is my timing wrong? Yes, my time is wrong. So on the stream it looks like it's 11:30, but it's not. So I'm going to have to reset my clock for a second, and you're going to see a clock for a moment. That is really quite weird. Let's see how I can do that. Well, nothing changed. Hey, guys, what time is it where you are right now? So, where I am now, it's 5:43, and where you are, it's 10:43. Okay, interesting to know all the different time zones that we are in. But on the stream, you can see that it actually shows a very wrong time. So I'm not sure how it is possible. Maybe I can do something like this. Okay, yeah, I think now I actually managed to fix the time. Yeah, that's better. And that means that there's not a lot of time left for day 16. I will go on for 5 more minutes and then take a little break. I'll keep the stream on because I do need to have a bite and some coffee. Definitely need some coffee. So we can keep going for a few minutes. And are you all going to solve part 16 when it is released? I guess you are, most likely. That's why you're all online and waiting. Oh yeah, I should not make a habit of editing my code while I'm debugging it. Okay, state is different is true. Okay, good news. And we keep going. So actually, let's just run the whole thing. Oh, look, it keeps going. It's now actually different from before. Yeah. Okay, can we make this look a little bit better? Yeah, we found it. Oh my god. It found a star. Oh, and where is it? And how many steps did it take? Oh man. Okay, so if we found it, we have to do something. We have to... yeah, I'm not keeping track of steps at the moment. So it was that copying error, and it didn't matter that I was getting a Yoshi-shaped output. That made my camera lag hard. Oh, okay. That can be. My camera has a lot of lag issues actually, and I don't know what is the problem. I think it's CPU overload. So, but I'm just gonna quickly go and try to count the number of steps. So we have... the steps are in the visited location. That's where I store them. And so if we find the goal... Where do we find the goal? Then we're breaking. And let's print number of steps. Maybe I'll make a variable for that. Can I just not call it steps? Or am I overriding something then? Because PyCharm is actually telling me that it's not available, this name. It's calling it steps for some reason. No, actually, I don't have the term steps anywhere, so why is it telling me to add an underscore in the end? Silly Python, silly PyCharm. Okay, so we're breaking and we're printing. Let's print the steps. Let's print the X and the Y position. That's all we need, kind of. And we'll run it again. And we have 258. And I think... No! Oh, I added a comma by accident. Oh no. I think I cannot submit right now. Oh man. Okay. Well. We should be able to also get part 2 right away, I think. Not sure. Well, actually, I don't know what part 2 is going to be about, so if it's going to be anything else than just giving some metric that I'm already collecting, then it's not going to be possible to solve it on time. So, how many seconds left? Oh, thanks, Crespel, that encourages me. Okay. Oh, it's copying the comma by default when I double click. Still 2 seconds left. Okay, let's do it again carefully. Submit. Yes, it's correct. Okay, that's great. Now we can go to part 2. And I am rewarded with a beautiful star. And how much time do we have left? We have 12 minutes. That gives us a little bit of a chance. I'm going to commit. So I don't want to mess up anything. I'm going to commit day 15. Day 15, part 1. You quickly repair the oxygen system. Oxygen gradually fills the area. It starts in the location containing the system. It takes 1 minute for oxygen to spread to all open locations that are adjacent to a location that already... Okay, yeah, so it's spreading one step at a time. Diagonal locations are not adjacent. Okay. Suppose you've used the droid to explore the area fully and have the following map. Okay, so the oxygen is spreading, and what do we need to answer? How many minutes it takes to fill the... How many minutes it takes to fill everything with oxygen? Well, that looks like... Oh, okay, it's not just a matter of... It's not just a matter of how many open positions there are. Basically, you can have a look at the number of the depth in your breadth first search map. So let's look here. We're doing a depth first search. Excuse me for this ugly overlay thing. Yeah. So we're going from start and we're exploring a bunch of areas, and we never do visit places twice. So this is our tree, and basically how many steps does it take to fill everything? It's basically the height of the tree. But we shouldn't start at the start position, we should start at the oxygen position. Yeah. Okay, so we have to run the same thing basically again from the oxygen position, but now without a robot. And I haven't explored the entire map. So the goal, I'm just going to keep the goal separate. The goal is none. Then here I will do goal equals the steps and the position, like XY. And then we don't break, we just continue to explore the whole map. And then we should have a grid in the end with the whole map. And I'm going to now actually store it. Maybe I shouldn't. Maybe I don't need to actually. I already have visited visited locations, which contains all of the positions. Okay, so when we're done, which means that we have no more locations to visit. So while to visit is not empty. Now we have a map. Yeah? Part 2 starts right here. And let's see if it's fast enough. So actually I'm quite happy with the way I solved this problem. Keeping robot state is quite efficient. Whatever, you're following me. Hey Gyro, thanks. I do come online every day before the start of the puzzle. And I'm going to have about a few hours every day. So please join in tomorrow as well. So let's see how fast this is actually. It is okay, but it is printing a lot of things. So without that, it is going to be faster and faster. Let's not commit, but run. Very similar symbol on my screen. So that takes about a second or two. So we'll have 1 second of delay every time we're trying something. So we're gonna do a breadth first search from the position of the oxygen tank. So to visit, let's say that we, how does it work? We have a starting node. Maybe to visit is, okay, to visit is the starting tank. I'm going to put it in a separate scope because I don't want to kind of mess up my variables. To visit is a set which contains only the goal position. So goal has 2 items in it. Where do I save it? The steps and the position, and it's the second part. And why can we not make a list like this? It can be replaced with a set literal. Okay, how does that look? Like this. Oh, okay, so this is a set apparently. So if you write a dictionary syntax without keys, then you're getting a set, kind of. And then we have visited. That's also a set. Whatever, you're following me, that sounds so casual. You're so funny, userman. It was someone with whatever in their name, but yeah. Okay, so let's do this quickly. We need to pop stuff. Oh no, and I'm having a list, so that doesn't work. So we do it like this, and so while to visit, and then we have, we are gonna pop it. We're popping the first item to do breadth first search, position, and then the new positions are going to be same as before. We are using this little logic, and we have the direction. I don't care about up, north, south, or down, whatever. We just need the deltas like this. And next position is this one, and if it's not in the visited list, and it's not in the to visit positions list, to visit, then we're going to add it to visit, and I think it should be append, yes. Next pos. And of course we need to see if the next position is not a wall. The presence of a colon makes it a dictionary. Yeah, that's kind of how it looks like. And why is this not okay? It shadows the name. Whatever. And we need to use the position. Okay, actually let's extract it like this. We have 5 minutes left. I'm confident that I can do it. And we're only going to visit that position if it's not a wall. So let's extract those 2 dimensions, and we can check it in the same if statement. If our wall, so we have visited locations, think I called it visited also, so I should use a different name for that. So locally I'm going to call it part 2 visited. Like this. And if visited, new position y and x is not a wall, that is the first value in the tuple, I think. Yes. Is empty, then we're going to explore it. Or maybe if it's not a wall, like this. Now my PyCharm has crashed a little bit and it's not responding, but we are back online. You wonder if today's is gonna be int code. I also wonder. Sorry if I'm not gonna respond too much to the chat in the last 5 minutes. I still haven't made coffee yet. Let's go, I guess. And then we need to know how many steps we went deep. How would we know how many steps we took to fill everything? Actually, I don't know. So we're checking out. We need to know the depth, basically. And the depth is the number of steps. So actually, we need to know the furthest. Basically, that's it. We need to know the distance to the furthest point that we can visit. So when we visit a position, let's keep also the number of steps that we took. Steps plus 1. And to visit we'll have steps like this. And hold on, to visit will contain the goal and the number of steps. That is 0. Although I'm not sure if the first oxygen tank also takes a minute or not. The only location which contains oxygen is the location of the repaired system. Okay, so it already contains oxygen and we can count it as 0. And why do I get so many highlights here? Oh, because I'm extracting from the wrong position. This is where we keep the number of steps. Hey, come on. Steps. We have 2.5 minutes left. Heart rate is going up. I have a smartwatch right now. It says that it's actually 59 minutes. I think my clock is going bad. Quite bad, actually. Alright. Then I'm going to actually reset my clock. Again. Refresh sometimes. Well, what shall I do? It already started. I'm not sure. Should I finish this? I am so much almost finished. So that's what I'm going to do. I'm going to finish this part. And then after I'm done, I'm going to get a coffee and then work on day 16. So you can stay here if you want. Just keep the stream open or mute it if it's distracting. And check from time to time if other people have solved day 16. In any case, good luck to everyone who is starting now. I am not personally trying for the leaderboard. As you can see, I'm taking my time. It would be a little bit more boring to see me code, trying to be as fast as I can without saying anything. But I do join the leaderboard that is right here. And you can also join it. I will paste the code again for those who haven't joined yet. So you can be on the leaderboard on top and compete with some peers of this channel. So continuing on part 2 of day 15. Oh, you joined it and your name is Sharkbound. Okay, that's something I didn't know. Let me take a note right now. Username 2 is Sharkbound. I'll change it a bit later. Okay, so we're taking the steps and then once we're done, basically we have those steps and then we need to get the maximum of all of the visited places. So that means I'm going to save it into the visited list also. Right here. So that's actually the previous steps and I'm going to keep it like this. and the current steps is going to be previous steps plus 1. Although not really, no, yeah. Okay, so that's the one I visited, and visited will now contain add, append, push. No? How do I add something to a set? Update? No. There's no function. I'm going to use set and see what that does. It has add. So it seems a little bit different, or at least PyCharm doesn't recognize it in exactly the same way. So we need to add the position? No. So in the end it is going to be a dictionary. So an empty list like this is a dictionary, and it has X and Y, and the number of steps for that was the P steps. And then we're going to just wait, I guess. Wait, how do we find the maximum? Isn't it just the max of the values? Yeah, I think so. So we're printing and running it. It's finished, but we don't see anything because I didn't actually run part 2. 372 steps. Let's have a look. Yes, and it is correct. Wow, okay. Actually, I was so far with my solution yesterday, and I spent more than an hour or 1.5 to actually get the right answer in the end. Hey Emily, good morning. How's it going? Are you already starting on day 16? So part 2 of day 15 is done, and I didn't finish for day 16 if it just seemed like that perhaps. Just want to know what we're gonna work on. Are we gonna do any kind of, oh my god, FFT? Are we gonna build a Fourier transformation? Fourier, I actually don't know how to say that. Fourier, maybe Fourier. A Fourier transformation, FFT? I think so, and I think that is probably just a different name. We won't be doing day 16 until later. I will do day 16 in 5 minutes, maybe 10. I'm going to have a coffee and a little bit of food, and then I'll see you back in a few moments. I'll keep the stream open. You can stay if you want, or just come back in a moment. Good luck everyone, and see you in a bit.